Hello and good afternoon. Welcome to the first webinar series on design and 3D print with color. It's a pleasure to have you all here. I'm very excited. We have a lot of attendees, so that's really good for us. And it's also our first time to launch a webinar series on one topic. So we try to be really short and precise and want to give you an overview about different topics around color with Stratasys, basically. So just as a reminder, you've seen it in the invite when you registered. Today we'll be talking and giving you an introduction to color, which is mainly a theory and also a bit of hands-on for you. Then next week we'll do how to use color with GrabCAD Print, so apply what we learned today. Then we'll go to color matching the week after, and we'll end with how to use clear with color and texture. We'll share all the registration links again at the end of this webinar if you haven't seen them. But just in case you wonder who's actually talking, my name is Stefan Schuster. You see the nice picture on the left. I'm your host today, and I walk you a bit through the presentation. But it's much more important that we have our expert, our PolyJet color expert on the line, Michael Perci. Michael, can you give us a brief overview on your background and experience with color?
Yeah, hello and welcome to everyone. Thank you, Stefan, for the nice introduction. My name is Michael. My background of color, I worked 13 years for a 2D printing company called Heidelberg Printing Machines. And the last 7 to 8 years, I was working with Stratasys, or I'm still working with Stratasys in the training area. And was involved in the introduction of our color stuff and our new systems, which we launched the past years, which enable us to have the real color available for everyone.
Perfect. So you've got a lot of experience in the 2D and the 3D world, which will help us a lot during this session. Before we begin, to all of you on the line, you've noticed that you're all online in a so-called listen-only mode, meaning that you can talk, but we cannot hear you. But there are a few things where and how you can ask questions, actually. You can ask your questions along the presentations using the question tab you find on the right. Or the chat. There's also a chat which you can use to ask questions. Also, we've got the hands raised feature where you can raise your hand and I can then unmute you at the end of the presentation and you can then ask your question. So with that, let's begin.
So let's start with our introduction to color session of today. As you can see on this nice picture here, color makes the difference and can make your part look very beautiful. So we go shortly on the content, what we will do today. First topic is the understanding of color. That means we will try to explain you how color appears, which influence the color and how we create color. Then next topic will be the comparison between color model, RGB and CMYK. We will talk shortly about color gaumons and in the end the tolerance and measurements of color, which is important for us when we want to print something, that we have the right color and the right tolerance to measure. Good, so we will start with a short video. Enjoy, and then we continue.
Color is perhaps one of the most powerful aspects of any design.
Color is used to influence, to motivate, to inspire. Achieving those colors is of high importance to the design community.
You cannot choose and define the right colors without Pantone.
This project is part of our R&D team that works on the PolyJet technology.
For years now, Stratasys and Pantone are in discussion trying to find a path for cooperation, and it really took a leap forward in 2018, where our technology matured to a level that we can meet all of Pantone colors, and it was the right time to cooperate and validate our printers.
As a product designer, I work a lot with Pantone. We thought it's a very good idea to integrate that into our system, and Pantone thought the same thing.
So many people rely on the Pantone color system and the Pantone brand that having that available in the Stratasys toolset is very valuable. It's going to help improve the speed, efficiency, and realization of the design intent.
It's so exciting to be working with Stratasys, the lead in manufacturing 3D printing. Just to think how useful having a 3D lookup table will be to the designer. It's just exciting.
This is the first time in history where designers can digitally print directly from the computer and the color that they chose directly to a 3D object.
Pantone is just our latest and greatest feature, adding to the journey of becoming the leader in product designers tool.
So, welcome back. I saw that a few of you have written that there is no sound on the video. I, for myself, had sound. I don't know what was the experience for all of them.
But we will share all the presentation and also the video in the end, so you can watch it again with sound. It was just meant to give you a quick introduction on color and Pantone with Stratasys.
Okay, so let's have a look on color. Color itself is one aspect of appearance. Appearance is composed out of 4 pillars. That is the color itself, the gloss, the translucency, and the texture. All that influence the way we see the color, and that's what we so-call an appearance. Within this webinar, we will go over all of these pillars. So let's have a look on color itself. What is color? First of all, color is something is subjective and relative. On the physics area, color is a property of an object caused by the way the object interacts with the light, according to the wavelength of the light. You can see that, for example, on a rainbow. This is how the light interacts with the rain, and that's generating a color. Color is something relative. Relative means it strongly depends on the background and on the lighting around the specific color. That may influence your way you recognize the color quite a lot, and we will have some examples about that. And color is subjective. That means it is emotional, cultural, and everyone sees the color differently. In fact, you can even learn color. If your whole life somebody tells you this is blue, then for you this is blue. You never learned anything different. Another good example would be, you know that there are people in this world which have problems with red and green. So the question now is why they don't get injured when they walk across the street, because they can't see the lights, right? So the answer here is quite simple. On the light, on the top is the red and on the bottom is the green. These people just recognize everything in gray. So for them it looks the same, but they know on the bottom light they can go. So they learned the bottom one is the green. So that's an example for learning.
But wait, Michael, does this really mean that I see a different color on my screen than you see on yours?
Of course, I think so, because one point is that all our screens are different. Or you have a calibrated screen, what they sometimes use in 2D printing, but I don't think so. But in the end, every person itself has a different recognition of color. And this is why I think you see it differently than me. So let's have a look on the human eye. The human eye has 3 wavelength detectors, a long, a medium, and a short one. And this is why everyone sees color differently, because these wavelength detectors are different on each and every person. Some have a bigger long range, the other one a bigger medium range, and the other one short. So that is why everybody recognizes color in a different way. So next one is a kind of challenge for you. Just try to remember this red dot. We might get back to it later on this presentation. So keep your eyes on the red dot and try to remember the color. So as Stefan asked, does everyone see the same color? I don't think so, because color strongly depends on the lighting, the object reflectiveness or the shadow, especially the lighting and the angle of the color. You can make a test for yourself if you stand up and look to your computer screen from the left side and on the right side, you might see it differently than looking from the front. So that's a different lighting, and that gives you a different recognition of color. The same is when an object reflects quite hardly, the color might look differently. Another big point is the age. As we get older, our color receptors turn yellow, and so does the appearance of the world around us. Luckily, color perception is not just inborn, it's also a learnable skill. So you can train yourself. The next one is the color memory. And I have to tell you, the humans have a really, really horrible color memory. Even looking at 2 colors across the room, from each side to the other, it is useless to try to do a match. We have in our eye, let's say a symptom. This is when we stare for a longer time on the same point, our eyes get tired. So that means inside we have some chemicals in our eyes, and they start to disappear and begin sending incorrect informations to our brains. So if you stare too long at one color, it is impossible to match anything with your eye. Then there is a phenomena called simultaneous contrast, in which the background on which we are evaluating color strongly affects our eye ability to correct and perceive the right color. So again, the surrounding effects irritate our eye, and this is why we see color different when we have a different background. Let's have a look on the lighting itself. We see here 6 pictures, and I want you to have a look on this color palette the girl holds up. What we changed in each and every picture is the lighting. You can test that by yourself on your mobile phone, for example. If you make a picture and you put a so-called filter on it, this is nothing else than changing the lighting of the picture. So colors will look different by changing the lighting or the filter on your camera. So I got a question now for each and everyone. Please tell me, which color is this dress? I give you a little bit time to answer. Just have a look on it, and we wait until we have enough respondents. Okay.
Let's wait a few more seconds.
Yeah.
Final call for those that want to vote. Good. So.
Yeah, we have a winner, and
it
looks like the, yeah, looks like the most.
It's fascinating, really, because to me it's clearly white and gold, and so many people see it differently. It's interesting.
For me, it's light blue and brown. So yeah, but the majority of you see it dark blue and black. So interesting that we see different colors, right? But what about now? Yeah, all we do here in these pictures is change the background lighting, as you can see here next to the one which looks for me white and golden, or the one which looks for me dark blue and black. Yeah, you can see here the background color is darker, and here it is lighter. So it strongly depends on the lighting. So what we have to do, our task, is to generate a neutral background. And this is in the 2D and the 3D industry, the most important thing, that you have a neutral background. On the 2D industry, you print on white paper, and in 3D, we print on very pure white in our machines. So more yellowish your white is, more influence it has on the color itself. That's why we want to have a clear white background. So when you look on this
neutral background equals white background.
Correct. White is completely neutral. So when you look on this dress without the lighting, and we have a neutral background, it looks like this. So I didn't see that from the beginning, honestly. Okay. Another example for the surrounding effects is this one. You can see now two pictures. Hopefully you see two hearts, and from my point of view, they look a little bit different. What about you? Do you see a difference? So we start now another vote. Okay, some see the same. But most of you see a difference. I see a difference as well. But let's do and take off the background, and you will see that the color is the same. But
that's really fascinating, because it looked clearly different on the picture before.
Exactly. Yeah. So the difference here is that in the right one, the red is over the blue, and on the left one, the red is over the green. Yeah. So when you take off the background, you have the pure red or pink color itself. So this is why it's so important to print on a white background. The next point is the object reflectiveness. So the difference between something glossy and something matte. The color of the lipstick of this girl is, I think it's a girl, is everywhere the same. But on the left one, she put some, what is it called? Some extra stuff on the top to make it shiny. And that influenced the appearance of this color dramatically. Same is true for our prints on the 3D printer. If we print something glossy, color might appear differently than we print something in matte. So can you remember what I asked you a few slides before and tell me which red was the one I showed? I mean, I give you 3 options. This is quite easy now, but let's test. Looks like we have some different answers, but the majority has a quite good color memory.
Good, let me just share the results. So it's a mixed results, but most of you chose number 2, which I would have chosen as well if I was allowed to vote. So Michael, what do you say?
Okay, it's number 2, that's correct. So this is with 3 samples, but what if you have more than 3 samples? Will it be then same easy? I don't think so. This should just show you that the color memory is not that good of the human mind. So keep in your mind when you choose something and give it to production and you get the result that you can remember what you gave them. Best is by a color standard or by values, not with what you have in your mind. Good. So that's about the basics of color. We step now over to the next point, and this is the color systems. We compare now RGB and the so-called CMYK. Starting with RGB. RGB is a color system that depends on a black background. It's usually used for computer screens, tablets, everything which has a screen, even TVs, is depending on the RGB value. So you start from a black and you have 3 different LEDs, a red, a green, and a blue one, and they light up with different intensity, and by lighting up, they change the appearance of the color. So all these 3 colors together will result in a nice picture you can see here on the right. So you can call that a kind of additive process. You have nothing in the beginning, it's black, and you add light by LEDs on the top to generate a color. Of course, this is not what we will have in the real world. When you look outside your window, in my case, it's a sunny day today, and we have a lot of light. Yeah? So no black background. Therefore, we have the CMYK color. CMYK is depending on a white background, so maximum lighting. Yeah? And by applying magenta, cyan, and yellow, you take light away from this background to generate a new color. So this is a kind of subtractive process where the 4 inks subtract brightness from the background light or the white base. Yeah.
So I can see that C stands for cyan, M magenta, Y for yellow, but what does the K stand for?
The K stands for black. As you can see here on this picture in the middle, when everything is over each other, we can still not make complete black. The only thing what you get is a dark gray. This is why you get in this color system an extra ingredient, and that's the K for black. Does that answer your question?
Yeah, and why not B for black?
Because B is for blue.
All right, okay.
Just to don't irritate people, they use the K. No, it was left over. I don't think so, but yeah, this is the K stands for black. Good. So in the CMYK process, you will see here in the left a nice picture, but when you zoom in with a microscope or good goggles or whatever, you will see a lot of small dots. And these dots sitting next to each other, interacting with the white next to it, which comes normally from the paper, or in our case, the very pure white, it will generate a specific color. So it's the dots next to each other. So you see that we have a kind of challenge here. We have screen colors, which depend on black backgrounds, and we have real world colors, I call them like that, which depend on the lighting or the white background. That's why what you see on the computer is normally not what you get out on a print. It doesn't matter if it's 2D printing or 3D printing. It's everywhere the same thing. So it is different because we work on two color systems. On the left picture, you see the screenshot from the part, the original RGB file, and on the right one, you see a printed part with CMYK. There is a difference. The difference you can easily see by showing at these two columns here. The RGB can display more than the CMYK can actually print. Yeah, so on the screen we see more colors than we can see on a piece of paper or on a printed part, for example. So the challenge for us is to transfer a color from a screen to an output device like a 3D printer or a 2D printer. And this is done by so-called color profiles. When we have a look on the range, what each and every system can print, the big area here is what the human eye can see. And the biggest part of it is the RGB color. But the smallest one is the CMYK color gamut. So if you have, if you want to print a color on the down area, it is not within the CMYK color gamut. So what we have to do, we cannot expand the range with cyan, magenta, yellow, and black, but we can try to map colors and, for example, bring them as close as possible, or move the area we can print from here to here. But when we do that, to print something from this area, we can not print something from the top area here. That is why you need different color profiles. That brings us to the next topic. This is the color gamuts. As you saw in the presentation before, the color gamut is the entire range of colors available on a particular device, such as a monitor or a printer. A monitor that displays RGB signals typically has a greater color gamut than a printer itself, which uses CMYK inks. And no matter if it's 2D or 3D, this is the challenge. So the human eye spectrum is the biggest area. That's what we call LAB. Yeah, so the human eye color spectrum is the LAB value. The highlighted area from that is then the RGB color, which is made for screens, mobile devices, and so on. Then we have the color gamut of Pantone, which is also quite a huge color gamut, but not so big like the human eye can see. And the smallest area of it is the CMYK color gamut. And it doesn't matter if you use 2D printing or 3D printing, it is the same color garment because you have the same ingredients. So we have the smallest area what we can use.
But Michael, wait, in the beginning in the video, we saw that the J850, for example, the printer, is certified for Pantone, but this color gamut looks much smaller than the Pantone one. Why is that?
Yeah, the reason is that in the Pantone, the whole Pantone garment, you have fabrics like textiles, leather, jeans, or whatever. Yeah, you have plastics, and plastics are pre-mixed colors, not depending on CMYK, for example. So that widens their range of colors. We are certified on a specific color book, the so-called solid coated and skin tone color book of Pantone. And this is usually the main color book, what is also used in in 2D printing. Yeah.
Okay, understood. Thank you.
Good. That's about the color garments. So our last challenge is how do we measure and define tolerances in color? There must be a way to define a tolerance because somebody has to produce a part and the designer tells them, hey, print this part in this specific color with a specific tolerance. Therefore, we have this very, very simple calculation. Okay, it's not that simple, but this is what we call the calculation of delta E. All you need to know is that the delta E defines the lowest possible notable difference between two different colors. So 1 delta E is the lowest possible difference, lowest noticeable color difference. When we look at the top bar here, from the left to the right is 14 delta E. For those of you who have not experienced a lot with colors, it might look just like a blue bar. People who have learned a little bit to see colors will see differences, but it's very hard to see from left to the right. And this is already 14 delta E. The second one shows you the difference of 126 delta E, which is a huge, huge range, and you will see a difference. That means, okay, what is delta E? Delta E is the most common way to measure the difference between colors. It's a single number that represents the distance between two colors, and the delta E of 1 is the smallest color difference that the human eye can distinguish. Higher than 5 delta E is not longer relevant to speak in terms of delta E because the difference between the color is too big. And as I mentioned in the beginning, a designer defines a tolerance for the production by the delta E. Similar to, let's say, mechanical engineering, where the designer defines, okay, I need this part plus minus 50 microns. Yeah? And in the design world, they say, okay, I want, let's say, 3 delta E as the tolerance. You have to stay in that. And this is like everyone who's working with color defines his tolerances, even Pantone. Pantone has also color tolerances. So, what happens when you convert RGB images to CMYK? By converting, we use color profiles or with the so-called rendering intent. A color profile has different ways of representing these colors to a specific material. So mainly we use in our 3D printers the absolute and the relative color remetric. We also have some perceptual and saturated profiles, but mainly we use relative and absolute. The rendering intent determines how the colors are mapped, or let's say adjusted to this specific material. So this is our original RGB with the absolute color. We can see that in this blue transition area, we will have a big gap, huge gap, yeah, but are quite good on the yellow, green, acceptable, but we miss a lot in this area. The relative is better with the transition in the blue area, yeah, the light blue area, but in general is a darker rendering. That means every color looks a little bit darker. This is what you can do in your printer when you want to make something a little bit darker or lighter. Yeah? So you choose a different color profile. Look how it comes out. So in order to go from the RGB color space to the printer, to the 3D printer or the 2D printer, color needs to go through conversion. This is done with a color profile that is suiting to the inks, in our case, to the resin. Input device is CMYK. We go through a translation with a color profile and transfer it to the output device in CMYK. On our next color topic next week, we will go as well on how you can adjust that in GrabCAD. So to summarize, color depends on surrounding effects, such like light, gloss, texture, everything around. For transferring a screen color to a 3D printer, we use color profiles and different materials. And of course, different renderings for the different profiles and different materials. To measure color differences and define a tolerance, we use delta E, like the whole design community does. And for defining a specific color, the best is to use a color standard, such like Pantone. With a color standard, you don't need to worry about color memory or, oh, was this really the color I choose? I can't remember. This is a color standard. With a color standard, you drive better. And we are the first one which are certified on Pantone worldwide and trying to make you your life more easy by choosing direct Pantone colors. You will see that next week when we have our GrabCAD session, how easy it is to work with Pantone and to work with GrabCAD together. So that's it from my side. We will now open for questions, if
Perfect.
there are some.
Thank you very much, Michael. Very interesting stuff. To the audience, if you have any questions, feel free to raise your hand and I can unmute you so you can ask your question live, or you feel free to use the question tab. So right now it seems as if everything is clear. So thank you very much, Michael. I thought it was really, really interesting, and I'm very much looking forward to next week to see how we can actually apply what we learned today. But maybe you want to learn more actually. And can you switch to the next slide, please, Michael?
Sure. I was just looking for questions.
So there's the upcoming webinar sessions. You can see the handout on the right-hand side. You can download. If you haven't registered, next week we're going to talk about how to use color with GrabCAD Print, and then we'll move on with color magic and how to use clear with color and texture. And secondly, we've got a lot of content on our Stratasys Academy online learning platform. You will also find the flyer as a handout on the right-hand side to download, or you just go to stratasys.com Stratasys-Academy, and then you can visit the Academy and register to get an account. Here you will also find the webinar recording and the presentation, probably starting tomorrow or the day after tomorrow. And you can find a lot more information on color there. So if you already want to skip ahead and learn about the upcoming topics, you can see that as well. Michael, if you can move to the next slide. We recommend that you have a look at the PolyJet J-Series color learning path. You can find, you see the screenshot on this on display here. There's a lot of different steps. It includes some e-learnings, it includes some guides. It also includes some GrabCAD print tutorials and some videos. So there's a lot of nice and good information here. So if you want to learn more, please do register and look for this learning path. And then hopefully we'll be able to answer your questions. Let's check one more time before we say thank you and goodbye, if there are any more questions, because I can see, yes, there's 2 questions on the line already. Good. So Michael, can we print metallic or fluorescent colors?
No, right now not, because metallic color depends on flakes inside of the color and how the flakes are orientated. So in our case, it's quite hard to get the flakes in the material through our small heads and orientate them in the right angle that we see a metallic look on that part. Fluorescent might be possible if we develop in the future a different ingredient. So all of that depends on material development. And if we see that there is a need from the market for, let's say, special colors and special material, we can talk about that. And this is exactly what the 2D industry does, make special mixtures for special colors. And
good, thank you. And then we have a question if you can explain the difference between Pantone certified and Pantone validated.
Pantone certified and Pantone validated, that's a good question. We are validated. Yeah, we are validated to the specific color book. But what is the difference to certified? I have to find out and answer you later on. Can we note who was that?
Yes.
Who was raising that question?
Yes.
Good.
Yes, we'll get back to you. Perfect. And then there's a last question to you. If there does a technology exist that can directly print in RGB?
No, that's not existing because, yeah, again, it's a black background, so it's a completely different system, and you work with LEDs and not physical, physical ingredient of a color. You work with LED lights. Yeah, so it's a completely different system and cannot be 100% adapted in the real world.
Perfect, thank you. And then there's one last question, whether the Stratasys Academy learning path that I showed is actually free to register. Yes, it is absolutely free. We want to spread the knowledge, and it is free for all customers. Perfect. With that, thank you very much. We're exactly at 45 minutes. It's been a pleasure to me. It was very interesting. I hope you feel the same. I hope to see and hear you next week, same time, similar link, basically, when we learn more about how to use color with GrabCAD Print. In the meantime, stay healthy and see you next week.
Thank you from my side as well. See you next week.